this question asks us to express the null hypothesis and the alternative hypothesis in symbolic form. And the statement is, Carter Motor Company claims that its new sedan, the Libra, will average better than 26 miles per gallon in the city. Some key words there. Better, right? Better than implies greater than. The other key word there is average. That's another word for mean. So it looks like we're making a claim about a population mean. So the null hypothesis and the alternative hypothesis will both reference a population mean. We use a capital H with a 0 subscript for the null hypothesis, and we use a capital H with either an A subscript or a 1. Depends on how you were taught or what book you're using, but they all refer to the same thing. So null hypothesis and alternative hypothesis. The null hypothesis always, always, always is a statement of equality. So there's always an equal sign here, no matter what. What can change are the different inequality symbols that can go into the alternative hypothesis. The three choices are greater than, less than, or not equal to. So the statement said, will average better than 26 miles per gallon. That implies the greater than symbol. So these are the two hypotheses for that test. And that will be letter B. Anytime you see a null hypothesis that has anything other than an equal sign, you know that answer choice is wrong. And anytime you see any weak inequalities, like these, that's going to be wrong also. Okay? So remember, the null hypothesis always has an equal sign, and the alternative always has either the greater than symbol, the less than symbol, or the not equal to symbol.
What was the
This was the choice. If you look on the answer choices, this letter B is the correct one.
Oh.
What else? Good.
Oh, I was going to ask if you could do it in the explanation form with the lines. Where it's the critical value and the critical values and the Z values form, and then the claims.
We could do a hypothesis test if we had more information, but here we don't have any sample data.
Oh, okay.
Right, so they're not asking us to actually do a test, they're just asking us to write what the hypotheses are. Now there are some other ones here where they are going to ask you to do a test. Do you want to find one of those? Like number 24, for instance, is asking you for a test statistic. Right? You want to do that one? Number 24 says, assume that you want to test the claim that the paired sample data come from a population for which the mean difference is 0. So they're telling us that these are actually ordered pairs. We have 5 ordered pairs. And they're telling us what the hypotheses need to be. The null hypothesis is that the mean difference is 0. They didn't specify a greater than or a less than situation, so we default to a two-sided alternative. Okay. Now, because we have paired data, this is going to be a matched pairs hypothesis test, where we first have to compute the differences for those pairs. Okay, so we actually will subtract 7 minus 4, 6 minus 8, 7 minus 3, 3 minus 4, and 9 minus 4. And then those differences is what we're going to run the test on. Okay? So this is pretty easy to do, by hand. So our differences are, our D's are, 7 minus 4 is 3, 6 minus 8 is negative 2, 7 minus 3 is 4, 3 minus 4 is negative 1, and 9 minus 4 is 5. Right? So those are our differences. We can go through and do a traditional t-test on these differences. I know some instructors are really formula-driven, other instructors are very technology-driven. I'm going to show you how to do this on your calculator, and if any of you want me to go through and actually do the t-test calculation by hand, I'll show you. But I'm going to pull down the screen and I'm going to show you how to do this on your calculator. While the computer warms up the bulb here, those of you who have your calculator, we need to enter these differences in your list editor. So you're going to go to Stat and Edit. You're going to enter those differences into a list. Getting here? Go up to, let's try again. Let's just, if you want to clear the list, go clear, and then bottom arrow, and now you can type it. And also be careful as you're typing in those negative numbers, don't use the subtraction symbol, it'll cause an error. You want to use the negative sign down below. Once you've entered the values, you're going to quit out of the screen, so we're going to go second and mode for quit. And now we're going to go to our Stat Tests menu, Stat, and then Tests. And we're going to choose number 2, the t-test. Why the t-test? Because we're given sample data and we do not know the population standard deviation, right? We do have the original data. This mu naught is asking us for the null hypothesis value. What's the claimed value? It's 0, right? My list was list 1, but you may have your numbers in a different list. If your numbers are in a different list, you're going to have to change this to whatever list you're using. Do you know how to do that? Let's say your list is list 3. You would go second and then the number 3. That would pull up the L3 name. And when we go to calculate, it'll run the t-test for us, and there is our test statistic. It's about 1.292 is the value of t. So second click. So stat, tests, data, enter. Mu naught is 0. Mu naught to 0. Your list was what, L5? So second and number 5. And then go down 5.
She can enter the data, so she has to see it on that. Because you didn't enter the data, you would see how it's 0 there.
No, you actually have to type in a 0 there. So go back to stat test t-test, and I'll show you where that is.
There's 3, -2, 4, -1,
See right there? You need to change that to 0. You can leave that at 1 or empty.
But I said it's
That's the difference also. 7 minus 4
If it's a matched pairs, yes. If it's a matched pairs, yes. And the problem that we worked on with the mileage for the car, it was actually 26 was the claimed value. So it varies from problem to problem. But with matched pairs, the claimed value is always at the mean difference of 0. Any other questions? Sure. Anything else on this one? Now, when I work with my students, of course, I make them go top to bottom with these tests. Define what the parameters stand for, tell me what the hypotheses are, tell me the value of the test statistic, tell me the p-value, and then write your conclusion in everyday language. So I know that's not what I'm planning to do for the final because it's a time test and it's a little hard to ask you to do all that, but you should be able to do all parts of that. Okay? All right, number 20 you said? Yes. 20. Number 20 is asking us to find the minimum sample size needed when we're estimating an unknown population proportion. And they want the margin of error to be 0.05. They want our confidence level to be 99%. And they want us to use p hat is equal to 0.13. Well, there's a formula for this, and it's in the formula pages that you can use. For a confidence level equal to 99%, this means that we're going to be using a critical value equal to 2.576. Okay, that's also on your formula page. So if you don't know that one by heart, then you can look down at your sheet. So the formula says you take your critical value, right? And you're going to square that. Then you're going to multiply that by p hat, and then by q hat, and you're going to divide that by the margin of error squared. It's on your formula page.
How did you get 2.576?
It comes from the confidence level, and do you have your formula sheets with you? I'll show you where it is. Look down.
It's inverse norm, though.
You can go to inverse norm as well, but for 90, 95, and 99%, your critical values are in the positive z-score table on the bottom right. Okay? So you see the 0.99, it says 2.575. I'll change it to 2.575. I usually use 2.576. All right, but that's where you find it. Be consistent with the formula page. All right? So I just have to plug those numbers in now. My critical value is at 2.575. That gets squared. P hat was given to me as 0.13. How do I find Q hat?
1 minus p hat.
That would be 20.
0.87, right? So 1 minus p hat gives us q hat, so 0.87. And we're going to divide that by 0.05 squared. And n is the sample size. It must be a whole number. So if we end up with an answer that contains a decimal, we always round up to the next whole number. Even if the digit after the decimal point is less than 5. We always round up. So let me see what I get on my calculator. How do you get that?
209.963.
Yeah, I got 299.969-ish. So that means we need a sample of at least 300. Okay. And because of rounding, what you want to do is find the answer. If it's a multiple choice question, find the answer choice that comes closest to what you found. And whenever you're choosing between two answer choices that are similar, pick the bigger one. Because you always want your sample to be larger than needed than smaller than needed. Okay. Always use a more conservative answer. Okay. What's next? 18. 18. The amount of snowfall falling in a certain mountain range is normally distributed with a mean equal to 104 inches. The standard deviation, 16 inches. What is the probability that the mean annual snowfall during 64 randomly picked years will be greater than 106.8 inches? The key here is that we have a sample of 64. It's not a single year that we're choosing at random. We're actually choosing 64 years at random. So that means that we're going to need to use a central limit theorem. And we're going to need to adjust that standard deviation. Okay? So the way we adjust the standard deviation is we divide the population standard deviation by the square root of your sample size. In this case, because our sample size is 64, our standard deviation will be 16 divided by the square root of 64, which is 16 divided by 8, which is 2. Now, we have to calculate the z-score. The problem is asking, what's the probability that the mean snowfall for those 64 years is greater than 106.8? Right? Make sure I have that right, 106.8. We need to standardize this. We need to convert it to a z-score. So that z-score is going to be 106.8 minus the mean, which was 104, over the adjusted standard deviation, which is 2. So if you work that out, I believe that you get 1.4 for z. And so this question can be written this way. What's the probability that z is greater than 1.4? Everybody okay with where we've gone so far? Because we haven't answered the question yet. So if we're looking at this visually, here's our normal distribution. Here's 0, right? We're looking at z is equal to 1.4 and to the right. Those of you who prefer to use a z-score table, because you're looking at area to the right, when you look up the z-score of 1.4, you're going to need to subtract the table entry from 1, because that table entry tells you the area to the left. Okay? Those of you who prefer to use technology, you can use the normal CDF command. So that's under your distribution menu. And you have to tell it a lower z-score and an upper z-score. Well, the lower z-score is 1.4, and we have no upper z-score. We want to go all the way to the right. we still have to tell the calculator some sort of upper z-score. So we just need to be ridiculous about it. Put in a really, really extreme z-score on the right. Now, I think your textbook says put e to the whatever 99. You don't have to be that extreme. 10 will do. This is a very large z-score. You remember the empirical rule? 99.7% of your data in a normal distribution is within 3 standard deviations. So anything above 3 standard deviations is already extreme. So if you go up to 10, that should do it. Okay. So either way, whether you're using the table and subtracting the table entry from 1, or whether you're using the normal CDF command, you should come up with the same answer. And what is it in this case? Letter A? Because remember, area under that curve is equivalent to probability.
Yes. So we knew to divide by 2 because we did the square root of.
Because this was a sample of multiple years, so you have to adjust that standard deviation first before you compute that z-score.
Okay, so you don't just never just divide by 2. You have to start it first.
Correct. It happened to be 2 because that's what it ended up being in this problem. But it's not always 2.
Okay.
I think that's your question. All right, what's next? And just to give you an idea for how much time we have, we scheduled an hour and a half. So we can be here until about 3:30, just so you know where to spend your time.
19.
19 and 6. Use the given degree of confidence and sample data to construct a confidence interval for the population proportion P. So we're estimating P. And we have a sample size of 107. X is equal to 66. And it shouldn't say P hat is equal to 88%. It should say the confidence level is 88%. So that's a typo on there. Doesn't make sense to say that P hat is that because P hat is 66 over 107. You have it already? Yeah. All right. Look at that. Okay. So, how many of you use manual formulas to build these confidence intervals? No hands, so all of you use technology? You like to use formulas?
I use manual.
Okay. Because technology will do this so much faster for you and with greater accuracy because you're not rounding. Okay. So what you want to do on your calculators is you're going to go to Stat, Tests, and this is your 1 proportion Z interval. And they're asking you for the number of trials, which is 107. They're asking you for X, which is 66. And they're asking you for your confidence level, which you're going to put in as 0.88. They don't want a percentage, they want a decimal. Okay, so what did you get as a result?
B.
Letter B, from 0.544 to 0.690. Your calculator can be your best friend, especially in a timed test situation, what I suggest you do is that you study that stat test menu and know which options you're never going to use, right? Because there are some that you're never going to use. And know which ones you use for which types of problems, okay? So if you want to run through that together, we can do that real fast. I think it's very helpful.
Is there a way to do 20 on the calculator?
20, we did not do on the calculator. We have to use that formula.
Okay.
There's no command for calculating sample size. That one we have to do by hand. And then I'm going to come to your number 6. I forgot.
And 4.
And then 4? Okay. All right, so let's go to the stat test menu. And let's see what gets used and what doesn't get used. Z-test in this course really never gets used. Okay? That would be used if we're testing a claim about a population mean and the population standard deviation was magically known. So that's not going to happen. T-test we use a couple of different times. We use it when we're testing a claim about a population mean and you're using sample data. And we also use it in that matched pair situation like we did in problem number 24, where you have to calculate the differences for those ordered pairs, and then you run the test on the differences. Okay?
What did you say, population mean proportion?
When you're testing a claim about a population mean, and you're using sample data to actually run your claim. In other words, the population standard deviation would not be known. Okay?
Oh, the standard deviation not known.
The population standard deviation would not be known, so you're using sample results. The 2-sample z-test, you should never be using in this class. Okay? For the same reason we don't use a z-test. The 2-sample t-test we will use sometimes, and that's when we're testing a claim about the difference between two means, when we're comparing mu1 to mu2. So we have independent samples coming from two different populations. That's when we would use that. If you're thinking section numbers, that's section 9.3. Some people work in section numbers. Okay? All right? And for that matched pairs t-test, like we did in number 24, that was section 9.4. And that also was section 8.4. So 8.4 and 9.4, we use a t-test. Number 5, the 1 proportion z-test. Yes, you'll use that sometimes. That's if you're testing a claim about a population proportion. Testing a claim about a population proportion. 2 proportion z-test, we don't use in this class. Z-interval, we should not be using in this class. But there are some problems in Chapter 7 where they pretend that somehow the population standard deviation is magically known. That's sigma. If for some reason you have problems where they give you sigma, then you would use a Z-interval. But in this class, we don't play pretend. We know that that's not possible. If you don't know the population mean, it is impossible to know the population standard deviation, which is calculated from the population mean. If you don't know one, you can't know the other. All right, let's go down a little bit here. Whoops, too far. Sorry. T-interval you will use. If you're thinking section number, that was section 7.3. That's when you're estimating a population mean and you're using sample data. Estimating a population mean, estimating mu, and you're using sample data. 2 sample Z-interval you should never be using. 2 sample T-interval, yes. That's if you're estimating the difference for 2 population means and you have independent samples. So that's section 9.3 as well. Section 9.3. 1 proportion Z-interval, yes, you will use that. That's when you're estimating a population proportion. And so that goes back to section 7.2. 2 proportions the interval, you should not be using. Chi-square test, yes, you used that in section 11.3 when you were working with those contingency tables and you were doing that test of independence. Are the row and column variables related or are they independent? So that's for section 11.3. That chi-square goodness of fit test, you should not be using ever, in this course at least. Okay? Should not be using that one. Should not be using the F test. So this is the test of homogeneity, and this is analysis of variance, which we don't cover in this class. The linear regression t-test, you'll use that when you're testing for correlation. So that is section 10.2, and also section 10.3 when you're finding the line of best fit. You can use that command for both. And that's it in terms of this menu. If you know those commands and where to go, you will have a much easier time at getting through the problems without being rushed and without having to worry about accuracy. What I suggest, this is what I would do if I were a student, take a screenshot of this, print it out, cross off the ones that you're never going to use, highlight the ones that you will use, and write down what kind of problems you would use them for. And just study from that. Don't bring that to your test. Don't tell your teachers I told you to bring that. I'm just saying for studying purposes, right? Until you get familiar with that menu, that's going to help you quite a bit. Okay. All right, so let's go to number 6. In the batter's cage, we have what, 4 you said, right? 4 waiting in the wings? 4?
Oh, yeah. Sorry. I was reading number 6.
Number 6, use the empirical rule to solve the problem. The systolic blood pressure of 18-year-old women is normally distributed with a mean of 120 mmHg and a standard deviation of 12. So let's write that again. What percentage of 18-year-old women have a systolic blood pressure between 84 and 156? That's the question. What is the probability that a randomly selected woman will have a blood pressure between these two numbers? It's a single woman. So we don't have to use that central limit theorem where we have to adjust the standard deviation or anything like that. We're going to go ahead and standardize these two numbers. We're going to convert them to z-scores. So the first z would be 84 minus 120 all over 12. So that's, what does that give us? 44? It's an integer.
-3.
Negative 36 over 12 gives us negative 3, right? That's nice. And for the second x, we get 156 minus 120 over 12. Very conveniently, that gives us positive 3. So the empirical rule tells us that within 1 standard deviation of the mean in a normal distribution, we have 68% of our values. Within 2 standard deviations of the mean, we have 95% of the values. And within 3 standard deviations of the mean, which is what we have here, we have 99.7% of the values. So in terms of a probability, it would be 0.997. I don't know how the answer choices are displayed.
Yeah, I don't know why it goes to 2 decimal places, but
It's letter
D,
D.
right? Yeah.
Be letter D.
So 2 standard deviation was how much percent?
68,
95.
95, and 99.7.
Yeah.
That's the empirical one.
The 1, 2, 3.
Yeah.
Yes.
4.
All right, let's go to number 4, variance.
I mean,
Okay. I'm going to turn to the calculator.
yeah, because I
There's no
plugged
way
in
I'm
the
going to calculate
calculator
variance by
too.
hand.
I plugged in the calculator too, but I don't know why it wants me to get the square of the sample standard deviation rather than the population standard deviation.
Because this is sample data. That's why. You never ever use the sigma that your calculator displays, because the algorithm for what that means anyway, it doesn't mean that you automatically know the population standard deviations. It's a little misleading. So whenever we're using data, you're always looking at S, not sigma.
It's confusing because of my teacher, like if we're using all the data, he said that's like the population.
It is, but your calculator is not treating it as such. So it's correct. We use sigma for a population.
Yeah, I know, but
deviation.
every time we had like a problem like this, find the variance for the data, unless it said sample data, if it just said data, we would multiply the,
Oh, yeah. I'm going to show you how to not have to square anything. All right, because you don't have to square by hand. Let's show you how to do that. So I'm going to first enter the data.
in your list.
And once you have your data in the list editor, there is a variance command. There is a variance command. So let's quit out of here. And we're going to go second list, which is the stat menu. So second stat will get you to the list menu. Then we're going to go to math. So scroll to the right until you get to the math submenu. And if you scroll down, you'll actually see variance. So click on variance and then tell it where your list is. Mine was list 1. And it'll actually calculate the variance for you.
Yeah, that's what I got too, but then wouldn't it round up to 2.78? I mean 2.8.
Yes.
Why
So the answer choices are just funky.
Yeah, okay.
Yeah.
That's why I was confused.
I've never seen that.
What I did,
Here, I'm going to show everybody just in case they need to know as well. If you need to clear a list, because I see a lot of missing lists all the time, and I'm always charging my students $50 a pop for me to recover their list. So, if you accidentally delete a list, boom, it's gone. The way to get it back is you go to insert. See how it says INS over delete? So you go second and insert, and then type in the name that's missing, in this case L1, and it recovers it for you.
what was that?
Okay? And if you deleted 6 lists, you can get all 6 of them back. They're still in your calculator, they're just not being displayed. Okay? The other thing is, if you want to clear the list, obviously delete doesn't work. We saw what delete did. You want to hit clear, and then the down arrow. Having to choose that down arrow is a safety mechanism, so you don't accidentally clear a list. Okay?
How did you get to that variance again? I never seen
Sure.
L1 and then
Sure. Let's go back to it.
second.
You're going to go to second and stat, which brings you to the list menu. Then you're going to go to the math submenu. And then scroll down until you see the variance. Whoops, that went too far. The other way, which is I think the way you were doing to begin
Yeah.
with,
The
is
list,
to
1 bar stats.
do the 1 bar stats,
Yeah.
which is stat calc number 1. And then once you have that standard deviation, what did I do? Oh, I cleared my list, so. Just trying to find,
Yeah, and then it gives you the sample standard deviation on the top, and then I guess because it's sample data, I guess you
we
square.
always use the S of
SX,
SX,
yeah.
correct.
All right. Gotta talk to my professor about that.
I think I heard number 2, but I may just be imagining that. Did somebody ask for number 2?
Imagine.
Sure.
Instead of one line.
List heading. And scroll down to number 8. Enter. And then type in your listing. So 7. What number was it this time? It was 5, so it was second of 5. Okay, you have that garbage up in front, so we can go back. Okay, so let's see why it's not working.
It's really cool.
Oh, very interesting. List 1 has all the numbers.
Yeah, I feel like the TI-83 pluses work better than the new ones.
List, nav. Oh, I know why. You typed in L1 incorrect. What you need to do is go second, and then the number 1, and see how it says L1 right there? Okay, so go second and 1. You don't want to use your alpha key. Okay, what's next?
I have a quick question about number 11.
Sure.
Would it be easier if you calculate the probability of getting the first question correct and then you multiply the probability by itself?
Yes, exactly right. So the probability of answering correctly, if you have 4 possible answer choices, would be 1 out of 4 if you're guessing. And because you're asking about 2 questions, it would be 1/4 times another 1/4, which is 1 over 16. So it would be letter B. Sure. Okay. A sample of 4 different calculators is randomly selected from a group containing 17 that are defective and 36 that are not defective. What is the probability that none of the calculators are defective? A lot of keywords here. First of all, it said 4 different calculators. So we are sampling without replacement. Once a calculator is selected, it's not going back and have the opportunity to be selected again. That means that we're going to be working with conditional probabilities. Right? These probabilities are going to be changing as we make those additional selections. So we have 4 calculators, and we want all of the calculators to be good, not defective. So I'm just going to put that little label of G to remind myself that I want all 4 calculators to be good calculators, not defective. Okay? Why? Because they're asking me what's the probability that none of them are defective. That's the same thing as saying that they're all good. Right? So we have 17 calculators that are defective, and we have 36 that are good. That means that we have 53 total calculators. For the first calculator that is randomly selected, what is the probability that it will be a good one?
36 out of 56.
36 out of 53.
53.
Once that calculator is removed, How many good calculators are left? Only 35 to pick from.
Out of 52.
And there's only 52 total calculators left, right? So we have to adjust both the numerator and the denominator in that second probability. And we're going to continue making those adjustments for the third and the fourth. Okay? So we get 34 out of 51 and 33 out of 50. And you multiply. That's exactly right. And so, let's see what I have on my answer. Number 12, the right answer should come out to letter B, 0.201. And you can type it in your calculator all in one step. Don't be writing down intermediate things. 36 divided by 53 times 35 divided by 52 times 34 divided by 51 times 33 divided by 50, all in one entry. Okay?
What's the key to transform it to a fraction?
Don't worry about fraction. Just do 36 divided by 53.
No, I mean after that. After you do that, you get the decimal.
Fraction?
I don't think the answer choices are as fractions, are as decimals. So you're okay.
What about this for?
It's up to your
Math-
teacher
math
too,
one.
right?
Huh?
Math 1, I read.
Yeah, you need to go to your math.
Oh.
Right there, number 1.
Get it again.
Good. Okay, we're on a roll. What's next?
Independent sample.
23. The effectiveness of a new headache medicine is tested by measuring the amount of time before the headache is cured for patients who use the medication and another group of patients who use a placebo drug. These are independent samples. We have 2 samples that are not related. One group is given one treatment, another group is given a different treatment. So yes, independent samples.
What's the difference between
This would be a Z interval, right?
This will be a t-test or a t-interval, depending on what they ask you to do.
grand number 21?
No, I'm looking at 23.
Oh.
Well, wasn't it between normal PDF and CDF?
You don't use PDF ever, you want to use CDF always.
And inverse norm is inverse norm.
Inverse norm is if you have the area under the normal curve and you're trying to work backwards to find out what the z-score is. And the input that you put into that command is area to the left. So for example, if you're trying to find out what that z-score is, that's where you would use inverse norm. So you would use inverse norm, area to the left, which in this case is 0.10, and the output will be the z-score.
Can you do 15?
Sure. In a game, you have a 1 in 20 probability of winning $100, and you have a 19 out of 20 probability of losing $10. What is your expected value? In other words, if you play this game many, many, many times, in the long run, what are you expected to win or to lose? So this is a discrete probability distribution. And we can set it up this way. I can either win $100 or I could lose $10. The probability of winning $100 is 1 out of 20. The probability of losing $10 is 19 out of 20. The expected value is just another name for the mean of this distribution. And to find the mean, we multiply each x value by its corresponding probability, and then we add up those products. So we can do 100 times 1 over 20 plus negative 10 times 19 over 20. Make sure that you have that negative sign when you lose money. And so in the long run, if I remember correctly, yes, letter A, you're expected to lose $4.50 per game on average. Not one that is in your favor. Most games of chance are not in your favor.
Can you do 17 more, Robert?
We have a normal distribution. The mean is 60. Standard deviation is 4. Find the probability that x is less than 53. This is a single x. It's not a sample of multiple items being selected. So we do not have to use the central limit theorem. We don't have to adjust the standard deviation. All we have to do is convert this to a z-score. So we have 53 minus 60 over 4. So that gives us negative 7 over 4, right? Negative 1.75. And so this is the same thing as asking, what's the probability that z is less than negative 1.75? You have two choices. You can go and use your z-score table and look up a z-score of negative 1.75. Your table entry will be your answer. No adjusting is necessary because we're already looking at area to the left. Or if you're using technology, you can use the normal CDF command. You have to give it a lower z-score and an upper z-score. This is our upper z-score, isn't it? Right? We were going all the way up to negative 1.75. We want to go all the way to the left. So we just have to be ridiculous about our lower limit. Remember how we were ridiculous as an upper limit? What did we use?
10.
Z was 10. So what would be ridiculously low?
Negative.
Negative 10. What's that? You don't have to. In fact, you get the same answer if you were to use 5. So even 5 is ridiculous enough, but 10 is an easier number to remember.
Somebody needs the 99.
Yeah, and you get the same answer.
Yeah.
You get the same answer. And it's a lot harder to type in.
Yeah, it is. Oh, yeah.
So know that 5 will work, but 10 is just an easier one to remember. I get less questions when I use 10 than when I use 5. They're always like, why 5? But nobody ever questions 10.
Just use 10.
And I'm like, oh, 10. That works. Okay, what's next? 4.
Alright, cool.
Number 27.
27?
Yeah.
I think you can. You can. You'll be on camera, but that's okay. So here we have a linear correlation coefficient equal to 0.523. Our sample size is 25. And they want us to use a significance level equal to 0.05. The question is, do we have significant linear correlation? There's one way to answer this, and that is to use table A6, which has the list of the critical values for R. Does anybody have table A6 with them? If not, I can find it this way. have it? Okay, let me use yours just to show. Table A6 has 3 columns. Did you find it?
Yeah.
Okay, it has 3 columns. The first column is your sample size. So in this case, N is 25. That chooses the correct row for you. The second column is for a significance level equal to 5%, which is what we're being asked about. The third column is for a significance level equal to 1%, which is a higher threshold. Okay? Our absolute value for R is greater than that critical value. Now we've got big group, right? So in our case, we need to be higher than 0.398. And we are, right? And because our absolute value of R is larger than the given critical value, we do have significant linear correlation. That's it. You just have to compare your absolute value for the R that's given to you to the critical value for that correct alpha level. And if your absolute value is larger than what's given on the table, you have linear correlation. Okay. 13, there are 10 members on a board of directors. If they must form a subcommittee of 3 members, how many different subcommittees are possible? So we have 10 people to choose from. We want to choose 3 people. Does it matter how we order them up? No. Doesn't matter, right? It's just a group of 3. So this is a combinations problem with 10 items to choose from, and we're choosing groups of 3. Yes, there is an app for that on your calculator. You don't have to use the combinations formula yourself, although it's loads of fun. All right. 10 choose 3. Here's how you would put it into your calculator. First, you type in N, which in this case is 10. Then you're going to go to Math on your keypad. Go all the way to the right to the PRB submenu, that stands for probability. And look at option number 3. That's what you want, right? NCR. Math, PRB, then choose the NCR, and then type in the value for R, which in this case is 3. Start over. Type in the number. Math,
all the way across.
PRB, and then choose, and the permutations command is here as well, right? The NPR is what you would use if order matters. And they were asking you how many ways can you elect a president, a vice president, and a secretary, so that you're actually assigning people to a slot. You use the permutation command instead.
How did you get? Yeah, NCR.
Math.
And where's the map?
Right there. It's the third one down all the way on the left of your keypad, under alpha.
Oh.
And go to PRB for probability. And then you should see it as number 3 in that menu.
you said number, the other one, what was it, for orders, not, what?
Permutation, so it's NPR. Don't you get to the same menu? You still go to, like, let's say we were choosing 3 people out of a group of 10, but then we were assigning them each to a different role, president, vice president, secretary. We would treat it as a permutation problem. So we would type in the 10th first, then go to math, PRB. In this case, we would choose number 2 because order matters, and then type in the 3, and you see that you get a much larger number. Why? Because after you choose the 3 people, and there's a lot of ways to do that, 120 ways to choose 3 different people, then you're going to play around with different orders, right? For each group of 3, there's 6 different orders. So it's no coincidence that this is 6 times as large, right?
I didn't notice it.
Can you do 28?
Sure.
So like, the answer that's on the answer sheet, I don't get that. I don't remember that.
Okay. Number 28. Very similar to what we did in looking for correlation. You need to do that here as well.
What section is this on?
This is from section 10.3. In order for us to make a prediction, we first have to know if the correlation is significant or not. Because if it is significant, then we're going to use our regression line to make a prediction. If, however, the correlation is not significant, then our best predicted value will be the mean of the y's. So first determining whether you have linear correlation, and then using that answer to determine which of the 2 paths you're going to take. So this is number 28. So we have R is equal to 0.942, N is equal to just 4. This is the regression equation. This is the mean of the y's.
Wait, where do you see N?
It says 4. 4 pairs of data. Yield.
Oh, okay.
And then they're asking, what is the best predicted value? Where x equals 4.3. So going back to table A6, we're going to look at the row that says n equals 4 and determine if this is sufficiently large for us to say that we have linear correlation. So let me peek at what you have. I'm going to pick on you this time. Is it not even on here? Oh, wow. The old one does. Anybody have an older formula? Yours has it, right?
Yeah. Can you use table A5? 8950. Well, that's what's on A6.
Oh, I see. They're just labeled differently. Did I use table A6 last time?
Yeah.
Oh my gosh. I wasn't even looking. Somebody stopped me last time.
I didn't know. I thought it was maybe just my birth.
I think it's the different versions. The newer
I
version.
think so too.
I don't have
Arrow. Did you see my X and an arrow?
You should
It's
stop
not
me at
off. It's not
27.
even off by that much. It's the closest.
Well, let's get it straight though. Luckily, it's still on the board. So
Yeah.
our critical, I'm going to borrow this for a second. I'm going to give it back. Our critical value for number 27 with n equals 25 should be 0.396. Yes. It is off a little bit. We need to use the correct table. For this one, n equals 4, we need to be larger than 0.95. We're not. We're not larger than 0.95, so we have no evidence of correlation.
On A6, it's right. Unless theirs is different.
You have a different A6.
Oh.
That's the problem. They're using the ones from their textbook, and you're using the one that is online. That was the confusion. So for number 28, remember I said that depending on whether the correlation was significant or not, we would take one of two different routes for computing the best predicted value. If the answer had been yes, we have significant correlation, we would have taken that 4.3 for x and plugged it in here. But that's not what we're going to do. Because there's no evidence of linear correlation, which means that we're just going to use y hat as our best predicted value. And that's true no matter what x you're being asked about. Okay? So if there's no evidence of linear correlation, you don't have significant correlation, you're always going to use y hat as your best predicted value, regardless of what x you're being asked about. It's a fixed prediction. Okay. Why? Because this line of best fit is only reliable if we had significant correlation. Another one, section 10.3.
That's the answer.
The answer would be 12.75.
PD 26.
Sure. So in problem 26, they want us to construct a confidence interval for the mean difference. This is a matched pair situation. And instead of giving us the original data like we had in one of the previous problems, they're giving us the summary statistics. Now, who remembers where we go to if we have a matched pair situation on a calculator? We went through that menu. I told you the section numbers.
Ooh, match pairs. Stat test, T interval.
Correct. Stat test T interval is correct. Thank you, Shelby, for the enthusiasm behind that.
Well, I have found it.
And this time, we don't have the data, so you're going to use the stats option instead. And it's not going to ask you D bar and SD. It's going to ask you everything in terms of X. Doesn't matter, right? These are just variables. So where it says X bar equals, you're going to put in your value for D bar. Where it's asking you for SX, you're going to put in your value for SD. Okay? Sample size is 8, confidence level is 0.95. So what do you get for that one? Letter A. You don't have a list, you have the summary statistics. So you want to go over here where it says stats. Go to the right. Up. Right. Just clear out. Go over and enter. Now you can enter D bar as your X bar, SX. Clear out your screen. Everybody else okay? Is there anything not on this review that you wanted to go over?
It's number.
Yeah.
Okay. I'm going to read it out. I'm going to write the key points on it. It says, a manufacturer considers his production process to be out of control when defects exceed 3%. In a random sample of 85 items, the defect rate is 5.9%. But the manager claims that this is only a sample fluctuation and production is not really out of control. At the 1% level of significance, test the manager's claim. Okay? So, let me write down what we know. We have, what number was it? This is from a different, I guess a test. That looks like the alternative hypothesis, that the percentage or the proportion of defects is less than 3%. I'm going to write 3% is 0.03. The null hypothesis is always a statement of equality, so I'm going to set that equal to 3%. Those are the claims. Now, what's the sample data? The sample consists of 85 items. And in the sample, the rate of defects was 5.9%, which I'm going to write in decimal form this way. And they want us to use a 1% significance level. That's our alpha level. Okay. This can be done on the calculator, or you can do it with a manual formula. If you are using the calculator, however, it's not going to ask you for p hat. It's going to ask you for x. X is the number of successes in your sample. So if you're using your calculator, you need to calculate x by multiplying your sample size by p hat. So x in this case is 85 times 0.059, and it has to be a whole number because this is counting the number of items. So what does that give you on your calculator?
5.01, so this is 5.
5.01, so it's just 5. Right? You round according to the normal rules of rounding. So if you go to your calculator, let's see if you guys can figure out the command. It's under the stat test menu. What's the right command if you're testing a claim about a population proportion?
Segment is
Z test.
The one prop z test. The one proportion z test. Okay? So you're going to go to stat, tests, one prop z test. It's going to ask you for your sample size. It's going to ask you for x. It's going to ask you for, I think that's it. Oh, the claimed value of p. So it's going to ask you what's your claimed value of p, and you're going to put in 0.03.
This statistic, test statistic, Z is 1.5577, so it's 1.56.
Okay, round. What about your p-value?
0.94035, 0.9404.
That's not good. We want our p-value to be very, very small, right? In fact, we wanted our p-value to be smaller than 0.01, and that didn't happen. So we are defeated, which means that we failed to reject the null hypothesis, right? We failed to reject the null hypothesis. We do not have evidence against the claim that the population proportion is 3%. In other words, what does it say about the manager? He's actually kind of right. This was a part of expected fluctuation, right?
My calculator says error.
Your calculator says error. Let's see. X, remember it's 5. You're putting in your
Oh,
p
shit.
hat. And I think that's about all the time we have. I do want to encourage you to ask any additional questions you have before your final. First of all, your instructor, who is going to actually build your exam questions. Also, our math lab in the Academic Success Center. Make sure that you go over there and use their tutors. Make sure that you connect with some of your classmates, and it's very helpful if you can work with another student from the same class. Okay?
Yeah. I learned like two functions. He's gonna take that.
Eventually, I don't need it, but I'm going to. Maybe I'll do it in the summer.
That's your test.
You don't need it either, do you? No, I don't need it. Maybe it's probably for passing, right? I don't know, man. They keep changing
Yeah, I
stuff.
guess it's still because you can have that too.
Yeah, I don't think we'll ever need it.
More than one. Maybe sign in or
No, I'm going to put the answers.
That's what comes down to 3 tiers. It's confusing because we have to do the MyLabs because we go to the.
Right, that's what we were saying, yeah, exactly.
Yeah.
Thank you very much.
You're very welcome. Good luck with your exams. I'm sure you'll do great. This is the answer key for any problems that we didn't get to.
Oh, let me.
Mine it says 21 skip. I don't know off the top of my head why. Let me look at why it says skip 21. Oh, because they gave you the population standard deviation.
Oh.
So that would be a Z interval, which we're not supposed to use in this class.
Which one is that?
Number 21.
Oh,
See how it gives you sigma equals 36?
oh, yeah,
That's pretend land. In
okay.
the real world, we wouldn't know sigma. So that would be a Z interval, just skip out.
Can you put down 29 and 30?
I'm sorry, but I have to turn this off, not on. There we go. I didn't put them on, that's what you're saying.
Yeah.
I don't know why I didn't